Hello class. Today we're going to cover how to conduct a hypothesis test to compare two proportions. To do that, we will be looking in section 9.1 at number 3, part A. We will be doing part B in another video. So let's read this. Since an instant replay system for tennis was introduced at a major tournament, men challenged 1,443 referee calls, with the result that 432 of the calls were overturned. Women challenged 780 referee calls, and 231 of the calls were overturned. Use a 0.05 significance level to test the claim that men and women have equal success in challenging calls. So for part A, they want to know what are the null and alternative hypotheses. The null hypothesis is H naught, that little zero. The alternative is H sub 1. The null always has an equal sign, so we're going to say population 1 is equal to population 2. The alternative, since we're trying to say there's a difference, will be population 1 does not equal population 2. Now that we have the hypothesis, let's move on to the test statistic. To do a test statistic, we'll need a formula to begin with. The formula for this test statistic is Z equals, open parentheses, P sub 1 hat minus P sub 2 hat, close parentheses, minus open parentheses, P sub 1 minus P sub 2, close parentheses, all over the square root, and make sure you have a big square root sign down there, of P bar times Q bar divided by N sub 1, plus, still under the square root, P bar times Q bar under N sub 2. Now let's find these values. P sub 1 is given to us, well, P sub 1 hat is given to us by X sub 1 over N sub 1. X sub 1 is 144, N sub 1, no, X sub 1 is 432, N sub 1 is 1,443. And when we reduce that, we get 144 over 481. I was getting a couple steps ahead. So let's use that same logic to find P sub 2 hat. This time it's X sub 2 over N sub 2. X sub 2 is 231, N sub 2 is 780. Okay, again, getting ahead of the game there. Let's repeat that. X sub 2 is 231, N sub 2 is 780. Reduce that, we will get 77 over 260. We need a little room, so let's go to the next page. And let's find P bar. P bar equals X sub 1 plus X sub 2 over N sub 1 plus N sub 2. So we get 432 plus 231. Make sure you use the actual X values. Do not use that reduced value we have from earlier. Over 1,443 plus 780, which equals 17 over 57. Next we find Q bar, which is 1 minus P bar. So we get 1 minus 17 over 57, which is 40 over 57. Next would be N sub 1, which is 1,443, and N sub 2, which is 780. Now that we have these numbers, let's go to the next page and plug them into our formula. So we get Z equals 144 over 481 minus 77 over 260 minus 0. We state in the hypothesis that P sub 1 equals P sub 2, so when we subtract them, we get 0. That's all over the square root of 17 over 57 times 40 over 57 divided by, let's go ahead and clean this up a little bit. So we multiply those together, and we're going to divide those by 1,443. And make sure your square root covers everything, And let's make it a little farther to the right. Next, we're going to add, still under the square root, 17 over 57 times 40 over 57 divided by 780. You plug this in and we get z is approximately 0.16. Now that we have the test statistic, let's move on to the p-value. So to find the p-value, the first thing we want to find will be how much area do we have to the left of z equals 0.16. So let me write that down for you. And while I'm doing this, you can go ahead and look in the z-table to find out what that answer is. And we will get 0.5636. However, we don't want to know what is the area to the left of z equals 0.16. That's a positive value. We want to find what is the area to the right of z equals 0.16. To find that, we're going to do 1 minus area to the left. 1 minus 0.5636, which will give me 0.4364. Now that just gave me the right tail. Since it's a two-tail test, I'm going to double that right tail to get my p-value. So p-value equals 2 times 0.4364, which will give me approximately 0.873. They wanted me to round to 3 decimal places on this one. And since I rounded, let's use the approximation mark. Now that we have our p-value, let's move on to the conclusion. We know that the p-value is equal to 0.873 approximately. And the reading told us that my level of significance is 0.05, which is the same thing as alpha. Level of significance as alpha is the same thing. And hopefully we can all agree that 0.873 is bigger than 0.05. And if p-value is bigger than alpha, that means we will fail to reject the null hypothesis. We will fail to reject H0. If you have any questions about this, feel free to message me or post in the discussion board.